If you're curious about drone mapping and photogrammetry, you want to know what it is and how it's used, you've come to the right video. My name is David Young. I'm the founder of a company called Drone Launch Academy. We've worked with, interviewed, made courses with dozens of mapping experts all over the country and all over the world over the last several years. So we're going to condense everything we know about mapping and get you started off in the basics in this video. So here's what we're going to cover. Number one, we're going to get a general understanding of what drone mapping and photogrammetry actually is. Number two, we're going to talk about the applications of drone mapping, when it's used, what it's used for, and the benefits, so why people would use it. Three, we're going to talk about some essential equipment, so drones, software, other things you would need if you're going to go out and do this in the field. Then number four, we're actually going to walk through a simple process of creating a map. What are the steps? What do you need to do in a very brief overview? Five, we're going to talk about regulatory considerations, so how not to get in trouble legally if you're going to do this. Six, we're going to talk about the drone mapping and drone services market outlook as of 2024 and forward looking. And then finally, number seven, we're going to give you a free resource to get started if you want something to download and take away from this video. So first, let's get a general understanding of what is drone mapping and photogrammetry. These might be words that you've never heard before. Maybe you've heard them tossed around in some forums, but let's just get a good understanding of what we mean when we say that. When people say drone mapping, typically they're referring to drone photogrammetry, which photogrammetry, the definition is the science of taking measurements from photographs. This has actually existed for a pretty long time. It got popular during the first world wars, World War I, World War II. People would fly over in airplanes or blimps, take pictures for surveillance, and then they eventually started taking multiple pictures and putting those pictures together. And there's a whole lot of science that goes into taking different pictures that overlap, finding common points, working out all the angles and all the different geometry that happens, and correcting everything so that you can make measurements across the photographs accurately. That's a little bit technical, but just think of it as many, many pictures that are taken that overlap so that there are common points among those photos, and then you're going to stitch those photos together sort of to create one master photo. And sometimes these photos can be 2D. They're called orthomosaic images is the official term, because if you think of a mosaic, it's made up of many pieces. The word ortho actually means straight or upright. So really you're gonna get this mosaic of images that is all looking straight down. It corrects all of the lens distortion and all the different angles of the buildings to where everything is perspective of looking straight down. And you're able to take measurements from that accurately. And again, there's a whole bunch of sciencey stuff you can get into with how those calculations are actually done. But in today's world, you can take those images as long as you know how to collect the input correctly, and a few things that we're going to talk about here in a sec, and how to then put them into the software with the right settings. The software will actually take care of all of that stitching and all of those calculations for you so that you can have a nice usable output. So that's photogrammetry, and people typically call that drone mapping because you're really creating a map of the Earth with your drone. So drone mapping, photogrammetry, sometimes those are used interchangeably. Now, another type of drone mapping that people might discuss or that might come into the conversation is something called LiDAR. And LiDAR stands for light detection and ranging. And you can think about this as it's a sensor that shoots out a ton of lasers in a bunch of different directions, a bunch of laser pulses, and it measures how long it takes for those lasers to bounce off of the Earth or a structure and come back to the sensor. And it uses that time difference to figure out how far away something is, and it starts to map out where objects are and create another virtual copy of what's on the Earth and what's on the ground into that sensor. And that's another way to create a map of what's around you by using a drone. So people might say drone mapping, they might talk about photogrammetry, they might talk about LiDAR, but these are sort of in the same family of uses. So we've talked about drone mapping, photogrammetry, what it is, LiDAR, what it is. Again, it originally got used back in World War I, World War II. It's advanced a lot. As history has progressed, they would do photogrammetry using manned aircraft, physical airplanes. They put these huge calibrated cameras in there and take photos that were stamped to different GPS coordinates, and it was this big, big process. Now into 2024, technology has come a super long way to where we don't have to do that anymore. Drones can carry a lot of the heavy lifting when it comes to doing photogrammetry and drone mapping on a smaller scale. If you're going to do thousands and thousands of acres, it might make sense to use a helicopter or an aircraft. But drone mapping now is so much more convenient because the GPS sensors are on board and everything has become so much more accurate with RTK and the software. So many things that we're going to talk about. But now it's come to a point where drones are being adopted at a much, much faster pace by professionals because of how good the technology now is. So with that said, let's dive into the applications and benefits, all the different ways people will use photogrammetry and why it matters. So when you're thinking about drone mapping and applications, it's really going to be useful in any situation where you need to document the current status or the current condition of some type of area. So like a construction site, a large piece of land, a building, something like that. If you need to document that condition at a certain point of time and it's bigger than you can just take a photograph with, photogrammetry, drone mapping, that is a really useful thing. So either that scenario or something where you need to actually take measurements. So you need to do some type of survey, or you need to measure how far one point is from another. You need to measure the volume of a stockpile, right? Anytime you need to measure or document a condition, drone mapping is going to be your friend. Let's run through some examples of when actual people have used drones for mapping, modeling, and how that helped. So the first example I have here is that the first metro line ever was going to be built in the city of Bogota, Colombia, and there were some engineering firms that were out there to do the earthwork and figure out, hey, how far do we need to dig down? Where do we need to move earth so that we can actually get down here to put the metro line in? Well, the civil engineering firm that was responsible for doing that work said that normally they would set up a bunch of survey stations, total stations, take a bunch of measurements, and do a bunch of data collection, and that process would normally take about 20 days for the area that they were trying to cover. But this time they used a drone, and instead of it taking 20 days, they were able to get the drone in the air, do an automated flight, capture all the data in about 45 minutes, and then take about 2 hours to do all the processing of that data, to do that stitching I mentioned earlier, to get an output called a point cloud, which is essentially that drone map that we talked about earlier, but instead of just an image, really there are a bunch of colored points in space that represent what is on the ground, similar to what I mentioned with LiDAR. LiDAR, you can get point clouds. Photogrammetry can also create point clouds. It's just one type of output. And it's really good for volume because it shows you where things are in 3D space. So they get this point cloud, and now they can see the actual volume of Earth that they need to remove in order to get going with their job. So it went from 20 days down to about 3 hours worth of work. The second example I have is a prison in North Carolina. Now, typically you never want to fly your drones anywhere near a prison. It's a quick way to get in trouble and get a bunch of guards running up to you, asking you a bunch of questions. But the actual prison staff was utilizing drones to create an orthomosaic image of the entire prison grounds. They were going to use it for operational planning, trying to figure out, hey, where do we need to staff people? Where might our weak points be? What are the different conditions of the property? They mapped over 800,000 square feet. So this is a good way for them to have a snapshot of where everything was, and that way they could plan out all their personnel and security procedures. So in our third example, we're going to talk about construction disputes. Construction disputes make up millions and millions and millions of dollars worth of litigation every year. Somebody says you didn't do this job right, or you billed me wrong for the materials, or problems on construction sites are very common. So where drones can come in is it helps you document the condition of something or the actual status of something at any given time, and it is fact. You have photographic proof that that's what was there. So in this case, we have a stockpile measurement dispute. One party said,
hey, I think you overbilled us for the amount of dirt that you moved. I don't think it was supposed to be that expensive. I don't actually think you moved that much earth from one place to the other.
And this company was actually able to prove, yes, we did, because here's the stockpile on the left of this picture. Here's the exact volume of this stockpile. And on the right, we flew that same stockpile again on this new date, and you can see the new volume of this stockpile of dirt. And the difference is what we moved. And so that's a pretty clear-cut way to show what you've actually done and the work you've accomplished. A similar example for a construction dispute was for a manhole sinking. So a civil engineering firm had was doing some road work here, and they had some drainage set up with a manhole. If you're not sure what a manhole is, it's literally just like a little hole tunnel where people can crawl down in to get to drainage systems and other things underground. So this manhole area, the whole thing completely caved in, and the company that contracted the construction company was trying to say, hey, you guys need to come and redo this. You're going to pay for it all. This is your fault. Well, since the construction company had taken regular progression updates, photos, and done a full map of that area on a regular time interval, they could show that, hey, at every stage of the process, we did this according to code. We laid down the right amount of gravel, we packed it, we did all these things, layered it up, did everything according to the actual plans that we have. And we can show from our maps that actually there was a problem outside of the construction site. There was something draining off that was from another property, and that water was washing away stuff that was causing all these problems. So it was really the other property owner that was causing the issues, not the way that the manhole was created or the construction process. So they were able to remedy that a different way, and this company didn't have to come out of pocket to fix a bunch of stuff. And the last example I'm going to talk about is construction coordination. And this one is interesting because this construction company was specifically using small drones that their employees could fly very simply and very easily in order to do construction coordination. So they would fly the site, they would create a map of the site, or even just get photographs of the site, and then it would all get uploaded to a central repository where people could make notes, tag things, look at the condition of things, and it kept everybody on track. Because as you know, with a large construction site, you got a lot of subcontractors, You got schedules. There's a lot of things moving. There's a lot of things coming in and out, and it can become a mess very easily. So getting a full and complete, accurate, up-to-date picture and condition of what everything is at a given moment is a great way to keep everybody on the same page and keep everybody moving forward on schedule. Now let's talk about some essential equipment and software. You're gonna wanna know, if I'm gonna do mapping, what kind of drones do I need? How much do they cost? What's the least I can get away with? And if I wanted to go crazy overkill, what does that look like? So let's talk about it. If you want to go on the way cheap side, really all you need is a drone that has maybe a 12 megapixel camera and can be controlled by some other type of automation software. You really can't do much large scale mapping or even medium scale mapping without having some type of automated system to make sure you're getting the right amount of overlap and the right amount of pictures in your data set. If you were doing like a 3D model of a house, you might be able to get away with manual stuff. Otherwise, you're gonna need something that can make an automatic flight plan for you. So drones that would fall in this category would be something like the DJI Mini 2. And again, this is not gonna give you world-class results, but you will be able to make some type of photogrammetry, some type of orthomosaic map and image with that drone. So right now you can get the Mini 2 on Amazon for about $379, and you will need software like DroneLink to actually do that flight automation. They support the DJI Mini 2, not the DJI Mini 2 SE. So if you have DroneLink plus a Mini 2, their pricing is based on hobbyist or professional. So if you're just doing hobbyist, you're just practicing doing it for fun, you can get the mapping functionality for $60 one-time payment. If you're doing it for professional use, it starts around $35 per month. Now, moving up from there, if you actually want to go get jobs, clients, or using this with your boss and they want more accuracy, better maps, you're going to have to move to something like the Mavic Air 2S. So with the Mavic Air 2S, you get a 1-inch sensor, a 20 megapixel image, and this is going to greatly increase the quality of the maps that you can make. It's going to give you better accuracy because you have more pixels in the same area, so it has more to work with when it's measuring, and it's just going to give you better looking maps overall. So Mavic Air 2S is going to run you plus or minus $1,000 right now, and you can also control that with DroneLink, like I mentioned. You can use the Mavic Air 2S with Drone Deploy, but only if you have a paid plan, and those are like $500 a month and up. So unless you already have Drone Deploy, you're probably going to want to get DroneLink if you're using the Mavic Air 2S. Now, let's say you want to get a drone that will get you, quote, survey grade or centimeter level accuracy, where you're going to be working on, let's say, construction projects or with surveyors or something where you need a lot more detail, a lot more accuracy. You're going to want to go with something like the Mavic 3 Enterprise with RTK. This RTK module, which is real-time kinematic processing, it's going to allow you to have more accurate GPS data in your pictures and in your maps, which allows everything to be adjusted a little bit better and give you really, really good positioning and accuracy. Now that Mavic 3 Enterprise drone is going to have a bigger than 1-inch sensor. It's actually called a 4/3 CMOS sensor. It's going to allow even more data to be captured by that sensor, and it still gives you that 20 megapixel size. Now, if you're going to use the Mavic 3 Enterprise, you're going to have to get the add-on RTK module, and DJI has a bundle that has that with some extra batteries for around $5,000 right now. So we went from $380 to about $1,000 to now $5,000. And then if you want to go mega Mac Daddy drones, really huge sensors, a lot more capability, flight time, ruggedness, you can go with something like the Matrice 300 series, and then attached to that, the Zenmuse P1 sensor. That P1 sensor is going to take 45 megapixel images, also has a mechanical shutter. It's like the Mac Daddy of photogrammetry sensors for drones. So the Zenmuse P1 sensor, which you have to buy separately, runs for about $6,800, and then you can attach that only to the Matrice 300 series and up, so 300 and 350. RTK drones. And right now, the Matrice 300 RTK is about $13,700. So all in, you're going to be $20,000 plus or minus on that system. Now, speaking of the Matrice 300 series, with LiDAR, DJI has come out with its own LiDAR sensors. So they recently came out with the L2 LiDAR sensor. And again, if you're like a serious LiDAR enthusiast, you might think this one is like not as good as some other ones, but for many people, it's going to do the job. And it is only compatible with the same drones that Matrice 300 to 350 series right now. And that LiDAR sensor is around $14,000. So if you were going to get the Matrice 300 and you got the P1 and you got the L2 sensor, you're going to be looking at somewhere in the range of $35,000. So that's a lot, but you could basically do any mapping job on the planet with that. Now, when it comes to the world of LiDAR, we're not going to get too much into it in this video, but you can get sensors all the way up to $200,000 and up just for the sensor. And then you're mounting those to either custom-built drones or larger platforms that can lift heavier objects. So LiDAR can get crazy expensive, but this is sort of at the entry-level point a sort of plug and play system for LiDAR users. Another thing to keep in mind is that if you are wanting to use RTK, you might need one other piece of equipment, which is a base station. This is going to send those GPS corrections to your RTK module on your drone. But if you're in an area that has really good cell connectivity, sometimes you can connect to a network called N-Trip. You can get these corrections over the cellular network. So something else to keep in mind, you might have to pick one of those up if you are in the middle of nowhere. Also, you should consider using GCPs, which are called ground control points. We're not going to get into too much detail about that, but essentially these are points on the ground that you can measure very accurately, and you can get the exact GPS coordinates for with your GPS base station. And then once you're processing your map, you can tell your software what those actual points are and can adjust your final product to make sure that it is accurate, so you can get that centimeter level accuracy. So if that's something you're going for, you would definitely want GCPs. And if you're using RTK, you might not need the GCPs, but it would be good to have them as a reference point and a checkpoint to make sure that your map is in fact accurate. All right, so I don't want to go too far over your heads, but just if you're wanting to get really accurate, that's some stuff to think about. Other just practical things you'll probably need are a hard hat, especially if you're on a construction site, maybe some boots. A lot of times when you're mapping, you're not in the most hospitable environments. It's always a good idea to have some safety cones block off the area where you're taking off and landing so people aren't walking through it. And if you're in an area with a lot of like dirt, grass, not a great place to take off, it's a good idea to have a landing pad. You could look at Hoodman. They make a lot of really nice landing pads that are have a good weight. You can throw them out, put your drone on top of them, keeps the dust and the grass out of your gimbal and out of your propellers. All right, now let's quickly talk about some software options. There can be really expensive software and really cheap software. So we'll cover the full spectrum real quick. Let's go to the really cheap side. Typically, these are pay-as-you-go providers. So there's no monthly subscription that you have to have, but if you want to just do one map, you can pay credits for just that map. So those are going to be software applications like Maps Made Easy and Birdie.io. That's BIRDI.io. They're an Australian company. They have subscription options to make things cheaper if you're doing a lot of volume, but these processing engines maybe aren't quite as powerful as some others that we'll mention in a second. If you're just starting off, it's a great option to learn and to get some practice reps in. Then two of the most popular ones, sort of in the middle to high end, are Pix4D and Drone Deploy. Drone Deploy is used a lot in construction right now with sort of reality capture, digital reconstruction of construction sites. They're sort of leaning in and focusing in on that area, where Pix4D is a bit more broad in its applications, from surveyors to construction, photogrammetry, a bunch of other stuff. So if you're in Pix4D, there's two options right now. There's basic, if we're talking about the cloud, right? So where you take your information, you upload it up into the cloud servers, someone else processes all that data for you and then gives you the map. So these are all cloud-based systems. So Pix4D has basic and advanced, essentially. The basic one is around $60 a month. The advanced is around $300 a month if you're paying monthly. And essentially, those just give you different credits for amounts of processing. So for instance, I used Pix4D Basic the other day, $60, and then I had more data I needed to process. So I bought more credits, I think about $100 more credits, and I was able to process my map. So I spent about $170, and I was able to get 3 maps out of that. One of them was just a regular 2D orthomosaic map. The other one, I was trying to do some 3D modeling. So if you're using Pix4D infrequently, you could always get the subscription for whatever credits you need, do your job, and then put your subscription on pause, and then reactivate it when you come back if you wanted to. And then if you're on Birdie or Maps Made Easy, a small map would only cost you a few dollars to process, $4 or $5. So you're looking from $4 or $5 up to $300 a month. Now, if you're getting into Drone Deploy, again, that's like $500 or $600 a month or more to use Drone Deploy. So really, that only makes sense if you're doing a lot of enterprise jobs or your boss is paying for it at a construction company or whatever. Now, there are some other options if you are processing on your personal computer. So Pix4D Mapper is a software that you can buy, and it's not in the cloud. You are actually doing the processing on your machine. Typically, you need a pretty powerful machine with a lot of RAM and a really good graphics card. I have one kind of over there in the corner that I use just for Pix4D processing. And with that, you have a lot more control over how the data is put together, where the tie points are. It's a little bit more technical, but you have a bit more control. And typically, you're not paying any type of credit system since you're using your own machine. So you can get Pix4D Mapper for $370 a month, or if you just want to buy a perpetual license forever, it's about $6,000. Now, quick caveat. If you are a student, so you have a .edu email address, taking grad school classes, undergrad, whatever, you can get it for much cheaper. Pix4D has great educational pricing, so go find their website and check that out. I think when I was in school, I was able to get a license for around like $100 or something. It's way cheaper. So if you're just using it for educational purposes or you're a student, check that out. Now, there are a bunch of other processing systems too. You can do things like reality capture, Bentley Studios. There's a bunch out there, so you can Google around, but I'm just giving you the most popular ones that I've seen a lot of people use that I've used myself. So now let's walk through the overview of how you can actually create a map or orthomosaic image. It's a 4-step process. We teach this in our mapping and modeling fundamentals course, but you do number 1, plan, number 2, collect, 3, process, and 4, analyze. Let's walk through each one of those right now. So in the first step of the process, plan, there's a couple things you're going to want to be doing. Number 1, you're going to figure out where am I flying and what is the airspace like in that area. Do I need to get prior authorization from the FAA? Is it controlled airspace? Check all of that stuff out. Make sure you're not going to be running into any TFRs or no-fly zones, and that you can actually complete the mission. Number 2, you're going to want to check your weather for that given day. A number of different things can affect the output of your map and model, such as things like how cloudy it is. If it's overcast, that's actually pretty good because there's not going to be as many shadows. If it is going to be really sunny, you might want to consider what part of the day you're going out to capture your model in, because as the sun moves, the shadows will move, and that might impact the reconstruction of your model if you're capturing data over a long time horizon. Another thing to consider with the weather is wind. With smaller drones, wind can really push those off track, and they might have a hard time flying those sort of grid patterns that you need to fly in order to capture an orthomosaic image. So if there's too much wind for your size of drone, it might not be a good day to go out and get that model. So weather and airspace are things you can check beforehand. Another thing I would highly recommend doing is hopping on Google Earth Pro or Google Maps Street View, whatever, going out and checking out the property that you're going to be flying at, or go there in person if you can, and look for obstructions. You want to look at how high the trees are in that area. Are there any cell towers? Are there power lines? Anything you could run your drone into that's going to mess you up. Also, you want to look to see, hey, the stuff that I'm trying to capture, the objects on the ground that I'm trying to get in my map model, are they visible from the sky, or do trees cover them up? Because really, you're only going to be able to capture what it is that you can physically see with your eyes if you're using photogrammetry. So if there's certain parts of that building or structure that you're going to need to get inside your 3D model, let's say, but it's underneath some trees or it's underneath an awning, you're going to have to make some allowances for that in your plan and come down and get a lower altitude shot underneath that awning, because you have to have images of that area in order to reconstruct it later in the software. And like I mentioned before, you want all those obstruction heights, so that way you can set your flight automation to make sure you're flying at a high enough altitude that it's safe, where you're still going to be able to capture the data that you want. Which leads me to the next part of the planning phase, is how much accuracy do you need? So there's a whole bunch of stuff you can get into here about relative accuracy versus global accuracy. Just know that relative accuracy is the accuracy within your one map. So if I measure from here to here, how confident can I be that that measurement is what it says it is in, let's say, length or volume? Global accuracy is how confident am I that that point on that map that I captured is that exact coordinates, latitude, longitude on the globe. So depending on what job it is or who you're working for, they might need a certain amount of relative accuracy, and they might need a certain amount of global accuracy. If it's for a survey, they might be very concerned about global accuracy because they need things that are on specific boundary lines and survey markers. But if it's just for someone measuring out distances on a construction site, you might just need relative accuracy. And then when you know which one is important, how accurate does it need to be? You could have relative accuracy with plus or minus 1.5 feet. You could have relative accuracy with plus or minus 1 inch. So you need to know that information from the client or your boss or whoever it is that's having you do this job. Once you have those numbers, it's going to impact how high you fly, which types of equipment you select, like which drones. The bigger the sensor you have and the more kind of expensive drone typically you have, the better quality image it's going to take and the more accurate you can get it, which means the higher you can fly and still get a similar level of accuracy as maybe a drone that doesn't have as nice of a camera, where you'd have to fly lower to the ground and closer to make up for that quality difference. So measuring accuracy is all about something called GSD, ground sampling distance. Again, too much to get into in this video, but just know you're going to want to know what type of accuracy you need so you can calculate your ground sampling distance so you can decide how high to fly and other types of flight planning considerations. Moving on to number 2 is collect. This part is the easier part. If you've done your job right in the planning section and you've planned out your mission, you're just going to want to set that mission up in a flight automation software like Drone Link, maybe Drone Deploy, Pix4D Capture. There's a whole bunch of software applications out there that you could use. My favorite is DroneLink, but you can set your mission up in DroneLink. You set your parameters, make sure you have your overlap settings where you need them. And again, this can vary on a bunch of different factors, but I generally get them in the 75 to 80% range. For most jobs, that might be a little overkill, but I find that it works for most things. You set your altitude, you set your max speeds, you make sure that all of the data is going to get captured where you need it. You set your gimbal angle, you set the direction of the grid, all this stuff that you can set up to make sure that you're going to have enough battery power and all that great planning that you did. You get out there, you set your drone down, you literally like hit one button and then you just watch it. And you're basically just a babysitter at that point, monitoring the drone, making sure that there's no aircraft in the area that you're gonna hit or run into, making sure that it's actually functioning correctly. It seems to be capturing all the data that you want. You might have to swap out a battery mid-flight. That's a common question we get is, well, what happens if the battery runs out in the middle of your flight? Let's say you're doing a big area. Well, most of these drone softwares are smart enough to come back, land, you turn the drone off, you put the new battery in, turn it back on, and it'll pick up right where you left off, continuing to capture data. So once it takes all those pictures and images that it needs, it'll come back, it'll land, you get your drone out, you get that SD card out, and now you just have a ton of pictures on an SD card that you don't know what to do with, which leads us to point number 3, which is processing. So I mentioned some processing software options in an earlier section of this video. What you're gonna do is you're gonna take all those images and you're gonna put them into some type of processing software. There's a lot of options out there. Pix4D is a common one. Drone Deploy is common for construction and some other uses. Maps Made Easy is really a good one for beginners. Birdie. There's also Open Drone Map if you know a little bit more technical stuff about getting things running on your own PC. Right now, I find it's easiest to tell people about Pix4D Cloud. The basic version is not super expensive and you can do some small maps with it. If you don't want to go out and spend money on that, I would just maybe use Birdie or something. So then you're going to upload all those images to their cloud server. And to be honest, there's really not a whole lot of settings that you're going to mess with in this section because they're doing all the heavy lifting on their end. You're really just selecting what type of output you want, maybe a few other options that you're selecting, and then you're gonna upload that data to their cloud platform. Maybe you'll put in some GCP information, that's the ground control point stuff, and then they're gonna do all the processing, and then you're gonna wait probably a few hours, depending on the size of the map, maybe less, and you're gonna come back and that map is gonna be finished, and then you can start playing around with the data. Now, in another software like Pix4D Mapper, what you're gonna do on your actual PC, there are a few more settings that you can mess with. You can manually do the tie points. You can sort of have a lot more control over the map and what it's processing and how it's processing it. So again, depending on the software you're using, you're gonna have different levels of control. But generally, this part is not that difficult, and the quality of your map is going to be greatly impacted by the data that you collected at the beginning and how good you were at the image acquisition process and getting the right kind of shots at the right angles, at the right heights, with the right type of gear. And if you do that and have the right kind of planning, you should get a good output at the end. But a quick word of caution on the processing side, you might get a little confused on the upload process if you have a ton of images. I always like to go through and review my images ahead of time to make sure that everything looks correct. So you can go through on your file explorer, start at the beginning and just arrow down, and you should see like the drone basically flying. You should see each image one after another. And as you just tap through, you should see the whole thing start to come together, and you'll be able to visualize that grid pattern. You'll be able to see that everything was in a cohesive direction. If you're tapping through and all of a sudden it jumps to another part of the property or another building, that's an indication that, hey, maybe it missed some data, maybe something's off, and you can go ahead and look through the pictures that you have to figure out if there was an issue somewhere in there. Another thing that you can do is typically a lot of software applications, after it's done processing, or sometimes even before it goes to process, it will show you the GPS coordinates of all of the images that you're about to upload. And you can sort of visually see on a backdrop of like Google Maps or something where all of those photos are. So you can see, oh, hey, it actually didn't grab this section of the property that I took, or you can kind of visually see if there's missing any locations of photos that you know you were trying to get. So once you're confident that you've uploaded all the correct images, you got all the right settings in there for whatever software application you're using, typically there's not a ton of them, you're gonna process, you're gonna wait, and then you're gonna get that data back. So the last step in our 4-step process is analyze. So we've got plan, collect, process, analyze. And this step can vary depending on what you're actually doing and what industry you're working in. Like I mentioned, drone mapping can be applied to a lot of different things. So analyzing is, what are you analyzing depends on what you're actually working on, what the purpose was. So I'll give you a couple examples just so you have an idea. One of the things we got asked to do, and we talked about this as a project actually in our mapping course that we have, is we got asked by a fast food restaurant to come in and evaluate their drive-through flow. They were thinking about adding an additional drive-through lane, and they were thinking about adding an additional entrance from a separate road. They thought about maybe busting out some medians that they had and putting some additional waiting parking spaces in there for people kind of like waiting on their food. So they had like 3 different scenarios and options that they wanted to explore, but they didn't know what that might look like and how that would work out. So what we did is we went out and we flew the entire property, the parking lot, the drive-through area, the restaurant. We did our crisscross pattern, our grid pattern, processed all those images through some software, and then we actually used Google Earth Pro. We were trying to do this as an example using just free tools to show you what can be done even with free tools. So Google Earth Pro is free. We were able to upload the orthomosaic image, which is a GeoTIFF file. Or upload it into Google Earth Pro. It knows where that is on the Earth, and it can overlay that on top of the satellite images. So the satellite image was an older kind of image and photo. So we had the brand new map on top of that. We could pin it right on top so you could see the differences. But it just gave some context for where everything was. And then we used the measurement tools in Google Earth Pro. They're not the world's best, but they did the job for what we needed. And we were able to say, okay, if you were to add a third drive-through lane over here, whatever that is, 8-10 feet wide. They gave us the specs at the time. And we were to run that all the way around. Here's how far it would come out. They'd know where their property boundary is, so they can see how close that might get, and they could sort of visualize the flow there. And then we said, okay, well, if you're going to put in 2 more parking spaces here that are X number of feet wide, here's what that would look like. Here's how much room you'd have to work with. If you're going to add an entrance off of this road instead of where it comes in now, here's what that might look like. So we painted these scenarios. We showed them all the measurements. We gave disclaimers on the measurement though, right? These are estimates, and I'll talk about that in a minute here. But we gave them this information just so they could visualize what are our options and what do we want to try to do and what might that look like and how would that work? How would that flow? It allowed them to take those scenarios to their management and figure out what they wanted to do. And they actually ended up going with one of the options, and they did it. They tore up the concrete, they redid their drive, they added a third drive-through lane, and they redid some parking per what we had shown them. So it's pretty cool now to actually go through there and see, oh, hey, this all this is redesigned based on some drone work we did for them. So pretty neat to see that. Another way you might encounter analysis, or some other analysis you might do, is like stockpile or volumetric. So measuring how much volume is in a big pile of stuff. So if you're in mining, landfills, any earthworks where you're moving big piles of dirt from one place to another or smoothing it out, that means money. So a big pile of stuff is worth something. Either it takes effort, man hours, and machinery to move it from one place to another, or somebody's going to be buying the material off of you, right? So whatever it is, the volume represents some type of dollar amount. And so you want to get accurate measurements so you know, hey, how much stuff do I really have to move? How much did I actually move? So if there's ever any disputes that arise, you can prove, hey, I took this 3D model of this stockpile on this date and here was the volume. And then 3 weeks later, I did the same exact model on the same exact pile, and here's how much less material is there. So therefore I moved this much. That's used a lot in like dispute resolution. If people want to dispute bills or inventory amounts, things like that, this is a great tool for that. Other types of analysis you might do would be for construction sites who want just regular monitoring. They want layered data of, hey, here's what we had on this date. Here's what we had on the next date. Here's what we had a week later, because they're going to use that to see what work was done over time, maybe manage their subcontractors. So again, it might not even be measurements. It might just be visually observing the status of a given place. Another example would be my friend Root Patel. He got hired to do a big mapping job for a smart cities project. They wanted all these 3D visualization of acres of land downtown, like large area. So he had to use 2 different types of drones, fixed wing drone at 400 feet, like a Phantom 4 down for like the facades of the building. He even used some ground cameras to fill in some of the details. And he worked with this architecture firm where they built like literally a 3D model of our entire downtown area. So if they have a new building development proposed, they could literally render that in their architectural software. They could put it in so they could see how it would look in the city with all the other buildings around it and how that might work and how they can do that. So urban planning, smart cities, his analysis was just literally creating a 3D model for people to make future urban planning decisions off of. So no matter how you're using it, there's going to be a different use case, whether you're doing engineering, whether you're doing surveying, construction work. Your analysis is going to just be dependent on that. So I hope that gives you some context and ideas of different ways that can be used and different analysis that you might have to do for a customer or for your boss. So now that you know the process for creating a map, the 4-step process: plan, collect, process, analyze. Now let's talk about some regulatory stuff that you might want to consider so you don't get yourself into some hot water. First thing you need to do is you need to get your remote pilot certificate. If you're going to do anything commercially with a drone, you have to have your remote pilot certificate. A lot of people call this a Part 107 license. Really, all you have to do is go take a 60-question test at an FAA-approved testing center. And there's going to be topics on airspace, weather, regulation, loading and performance, airport operations, a bunch of aviation and drone stuff, right? They're going to ask you 60 questions. Got to get a 70% to pass. Once you get that, you get your little card in the mail so you can say you're an official commercial drone pilot. That just makes it so where you won't get in trouble when you're flying your drone commercially. And if you want some free resources on that, we'll post some links below. You can check that out in the description to help you if you're looking into that. So that's sort of the first hurdle that you have to get over if you want to do commercial drone work. Then if you're getting into mapping work, two things to consider as you're getting into this space. Number one is you might need to be careful around surveyor type work. So in the state of North Carolina, there's an ongoing case right now. We're in 2024. The State Board of Surveying or whatever for North Carolina is suing some guy who was doing some drone mapping work. I think he was taking photos, or maybe putting orthos together that had measurements on them. And they said any photograph that people are going to use to measure anything is technically considered a survey product. Therefore, you're not allowed to do it. You have to have an official surveyor license and pay your fees to the board and all that stuff, right? That is the most extreme interpretation of that I've heard in any case. As far as I know, that's only in North Carolina right now. I have a lot of personal experience, and I know a lot of friends that do mapping work and all over the country. And I've never heard anyone have any issues as long as they sort of abide by these rules and standards that I'm about to tell you about. So number one, they don't hold themselves out to be a surveyor. They're pretty upfront with their clients. Hey, I'm not a surveyor. If you need like a official survey of this land, like with a surveyor stamp that you can use to file blueprints or do permits or whatever, you need to go hire a licensed surveyor. Or the drone operator oftentimes will go partner with a surveyor to do that work if the surveyor doesn't use drones on their own, right? So you can partner with the surveyor if they need an official stamp. I've got a friend who has done that kind of work for, they're going to start construction and they need to do an official survey of the site before they do anything, start anything. So he partnered with an official surveyor, licensed surveyor on that. They got the stamp. Boom, no problem. If you're just taking pictures or you're doing things like I talked about before, like, hey, I'm just doing this for planning purposes. This is not like hey, this is your legal boundary. You're not saying, hey, these are the official coordinates of these areas. Something that would require a lot more precision or would require a surveyor to give the final approval on for it to be like hold up in court or something, right? They're saying, hey, I'm not a surveyor. If you need a surveyor stamp, we got to go find one. But I can do all these other things for you, provided that you know that I'm not a surveyor and that these should be taken, with a grain of salt, so to speak, if you're relying on these measurements. So if they're going to rely on measurements engineering plans and structural engineering stuff, like I would get a surveyor on that, right? But you just need to communicate with your client so they know who you are and what your skill set is. And as long as you're upfront and clear about that, I've never heard anybody get in trouble for anything like this other than that one case in North Carolina. So if you're in North Carolina, maybe you should tread a little bit more lightly. But again, I've been in the industry for 7-8 years, tons of friends who do mapping. I've done some mapping stuff, and I've never heard of anyone ever getting in trouble with the surveying board because they're not trying to trick people into thinking that they're surveyors when they're not, right? That's not really a good business model. So as long as you're upfront with who you are, what you can do, your capabilities, you should be fine. Usually I include a little disclaimer on the bottom of my work that just says, hey, this is not, an official survey. None of these measurements should be relied upon for like safety and yada, yada, yada. So this is just for planning purposes. I'll throw a little disclaimer like that on there so they're reminded, or in case somebody else sees that report and they don't know me, right? They just know that, hey, these are just to be taken for planning purposes and considered estimates. All right. So that's what I would consider. And the second thing, if you're going to do mapping, is you should really consider getting like an OSHA certification. So the OSHA 10 or the OSHA 40, especially if you're working on any construction sites, it's almost mandatory to get on construction sites like that. So you need a hard hat, boots, vest, and your OSHA certification. So go check that out. We'll put some links below if you want to do that. We don't provide any of that training. You have to go through some other OSHA training providers. But those are the things, regulatory things. Part 107, yourself a surveyor if you're not one, and then third, get that OSHA certificate. All right, let's briefly dive into some opportunities and what does the future outlook look like for drone mapping, drone services, right? Like, is this even worth your time? A lot of people are like, they hear, oh, the drone license market is, flooded. There's so many drone pilots. What's the use? And I would say it is flooded with people who aren't very skilled per se, but it is very possible to succeed and do very well. I know a lot of people who make good money doing drone mapping or using drones for real estate. I know people who make six figures in every industry of real estate, drone mapping, thermography, all sort of the major categories with drones. I know people who have six-figure businesses in each one, video production, but they are very good. They're very specialized. They know how to do marketing and selling. They know their industry very well. They're not just drone people. They're more like solution providers. So if you want to make money with a drone, you have to know how to solve someone's problem, not just get up there, throw your drone up. A lot of people go, I'm going to go get a Mavic and I'm going to get my Part 107 and I'm instantly going to make a bunch of money. That is not going to happen. It can happen eventually, but that's likely not going to happen at first. Just like you're not going to go sign up for a $20 QuickBooks, subscription and take one online course on how to do bookkeeping and all of a sudden have like a six-figure bookkeeping business. Probably not, right? Any business requires a lot of effort and work. You got to know how to do sales, marketing, all that fun stuff. So it's definitely possible, but it requires work. That's my first caveat. And then second, there's a lot of opportunities to make drones sort of an add-on skill to whatever industry you're in. So if you're in video production, mining, construction, surveying, any of those things, you're already doing that, engineering, especially civil engineering, adding a drone into your skill set is really going to enhance your ability to do your job more efficiently, safely, all that stuff. So the job market outlook, I've seen these reports, these industry survey reports that come out, and don't look at the ones that are for the total drone market, because those include drones specifically, like drone hardware sales, and that sort of brings the numbers down because those are a little slower than they have been in the past, just are less growth than they've seen. But drone services specifically, I've seen anywhere on the low end from like 15% estimated compounded annual growth for about over the next 5 to 10 years, all the way up to a report that said like 40% compounded annual growth, which is pretty insane. And again, nobody knows the future. They don't know. They're just making this stuff up. They're basing it on some data and looking at historical stuff and what the landscape looks like in the future. And based on their best estimates, here's what they think is going to happen in these regions and areas, right? So they're trying to make educated guesses, but that's really what they are, educated guesses. So somewhere in the range of 15 to 40%. But if you compare that to other industries, that is really good and fast projected growth. So when you're thinking of a rising tide lifts all boats, right? If you're going to be in an industry or you're going to learn a skill in an area, it's good to go into something that is growing and is going to be just more and more prevalent versus you're going to be fighting for a smaller and smaller pie, right? If you get in, the pie is going to continue to get bigger and bigger. So even if you're not the world's best or the greatest, you can still be successful in that field as it grows, right? So that's the best place to be. The pie getting bigger instead of fighting for a pie that's getting smaller. So that's what I would say. You can go look up, drone service market industry outlook report, and there's a bunch of stuff. When I Googled them, they all pop up. So, but when I checked it, I've looked at them pretty regularly. 15 to 40% was somewhere where I was getting. That was drone services as a whole. Now, if you want to look at mapping specifically, I've seen reports that show that mapping is sort of the highest earning niche within the drone services market. Again, you can go Google around, but as I've looked, that's what I found on multiple different reports or surveys. The number one 6-figure potential niche inside of the drone service market. So I really like it. I think it's a good place to be. It's only going to get more and more prevalent in more and more industries. So the more you can learn how to use it to your advantage, the better. So that's pretty much the end of our video, except I want to tell you about, we're going to put some free stuff below. So we're going to rotate out some freebies for mapping. So we might have a project proposal pricing template down there. We might have like a little mapping mini course down there that you can do. We're going to put some type of free resources down there. I don't want to call it out specifically because, over the next year or two that this video is out and relevant, we might change it up based on what's most helpful. So look below. We're going to provide some type of free resource if you're interested in learning mapping. In addition to a lot of the other links that I've talked about, we're going to try to put everything below so you have it all there. So you don't have to go hunting around different places on the internet. So we'll have stuff for part 107 down there. I have a whole nother video that I did on that process if you're interested in learning what that's about. But yeah, you made it to the end of this video. You're amazing. This is a very long video, I think. So thanks for sticking around to the end. Go fly safe, get some mapping done. I'll see you next time.